Welcome to this 10.7 update where I'll be covering Smartlink for you. So I'm just going to do a quick overview. Then we're going to cover some use cases, provide some details and caveats around Smartlink. Going to cover some configuration around Smartlink and what it looks like, then some best practices. Then we'll cover some troubleshooting commands, and then I'm going to finish off with a demo to link that all up. So hopefully then it all makes sense, and then maybe you can ask some questions after that. Please ask questions during the session, and the TMEs will try and answer them. So let's have a quick overview around Smartlink. Well, some of you guys might have heard about it already. Because we already support Smartlink in COMware in and AOS switch. So this is bringing a feature parity effectively into CX. So what is Smartlink? It's a redundancy feature. So if you've got, like in the diagram here, two links to another layer of the network, we provide some form of redundancy in terms of a switch over and a failback. It's a proprietary feature that only belongs to the HPE switch portfolio. It operates at a layer 2, so it's all about having a VLAN construct. And in terms of failover speeds, we're actually aiming in terms of our design goals to be less than 2 seconds. So that's the overall design goal. It's quicker than spanning tree typically. However, you'll find in certain use cases, you may be quicker than spanning tree, and we're getting sub-second failover. And then the interoperation, it will interoperate with AOS and COMware. The packet format in CX is the same as in the other products, so it will interoperate. So what are the benefits of Smartlink? Well, we're providing a loop-free connections up to another layer of the network. We're able to block one of those links without the use of spanning tree. We have a primary and secondary link. We have a rapid failover, as I said earlier, design goal less than 2 seconds. And then we can load distribute VLANs among links. So I talked about having one block, but we can still utilize that, and I'll talk about that a bit later. But it's a load distribution and not a load sort of sharing based on packets, right? It's only VLAN load distribution. So if the VLAN is not loaded, you're not actually distributing traffic evenly, okay? And the other thing is it's simple to configure. So what are the use cases? Well, typically, if you've got applications that are time sensitive, like video and voice, you can use it in that situation where it's less than spanning tree failover. So it's only in the failover situation where you are sub-second. And then a big one that seems to be really popular is really simplicity of configuring and deploying it. So in terms of operations, it's simple to configure and administer. But then there's the other thing about you could eradicate spanning tree. So if you're in a customer who doesn't have the skill set, or a small medium customer who doesn't want to work with spanning tree, this is a great option for them if they want to sort of eradicate it, or they don't have the resources, or they're coming up to speed on something. So again, it doesn't confine it to that. That's just possibly a use case. All right. Then you have, if you've got in a mixed environment where you've got COMware, AOS, and you want to bring CX in, again, you have the confidence level that you can bring these CX products in, work with the other products, and have a migration path as well. So they're the use cases. So let's talk about some of the details around Smartlink. And so let's look at some of the concepts, okay? So first of all, in Smartlink, we have something called a Smartlink group. And per switch, we have up to 24 of them. Typically, you wouldn't use 24 of them on a switch, okay? But they're there for you to use. So in terms of ports and lags, you can only have a port or a lag allocated to 2 separate Smartlink groups. And you'll see this later in the configuration. This helps with the VLAN load distribution. Then we have a concept of something called a protected VLAN. This protected VLAN is the VLAN you use to forward traffic that you're interested in effectively. Then we have a control VLAN. You have one control VLAN per Smartlink group. This control VLAN is required and necessary to enable you to flush packets. So we use this VLAN as a flush mechanism, okay, because we don't have spanning tree. Again, I've talked about the VLAN load distribution. We have a primary and a secondary link per group. And now I'm going to just quickly go over to the diagram so you can sort of get a view of this. So if I look here on the left, I've got my physical hardware in this triangle. It's layer 2, but I'm going to split it up here in terms of configuration. So I talked about the Smartlink groups. So I've got on the left side, I've got a Smartlink group 1 defined, and Smartlink group has got a primary link up to the west switch and a secondary group up to the east switch. And this is my first Smartlink group with 2 links. I've defined a protected VLAN and a control VLAN. The protected VLAN will go up on the west switch, and if there's a failure, it will go up, it will revert to the east switch under a failure situation. Now, if I look at the same switches, what I'm going to do is I'm going to configure another Smartlink group, but this way I'm going to switch around the primary and the secondary ports. So now my primary group is going to go to the east switch, and my secondary my secondary link on group 2 is going to the west switch. And I've defined some different VLANs. So you can see 2 to 10 here, 11 to 20 here, and I've got a different control VLAN. And in this way, I'm load distributing the VLANs. That's the main thing and this is the rule that I mentioned earlier, that you can only have 1 port to 2 groups, and this is how we load share. So let's carry on. So we have I've described that already. We have a primary forwarding link, a secondary backup link, which is always blocked per group. Now, the secondary link only unblocks itself if there's a failure in the primary. So they'll switch over. So the dash, in each case, the dashed line will become the active link under a failure situation. We can preempt on these as well. So that means if after a failure, the primary link comes back up on either side, then we can switch back to that primary link. And that might be because that link might be of higher bandwidth, that'd be a more favorable link. So you want to preempt back to those. Very important thing is we need to maintain a layer 2 loop, a ring effectively, because the control VLAN needs to be able to flush packets when a failure occurs effectively. Okay, let's move on to some of the caveats. Excuse the mistake up here on the slide. Supported platforms are the 8360, 6400, 6300, and the 6200. I'm not going to go through each of these points, but some of the important things when you're using VSX, ISL and MC lags can't be part of a Smartlink group. So where it says in these caveats it can't be part of a Smartlink group, they can still possibly coexist, okay? So there is a coexistence, and we'll see that in later on. Loop, for instance, Loop Protect can't be on the same Smartlink group, but can be on the switch. On both switches, Smartlink and spanning tree can be enabled, but Smartlink ports will not participate in spanning tree, okay? Think same as ERPS and Smartlink can't be on the same port, but can coexist. Smartlink can't be enabled on multi-chassis lags. That's a really important thing. You can't have a multi-chassis lag and have Smartlink. Multicast fast convergence isn't supported, but maybe it will be in later releases, okay? This is quite an important one as well. So for improved convergence, if you're using Smartlink and you've got uplinks layer 3, which you typically will have, we recommend putting the IP neighbor flood command to enable when the MACs get flushes, so IPs get learned quicker, so the ARP process is quicker as well. There's no MIB and web UI support, and I'll leave you to read that, but but basically this means if you've configured a VLAN, it has to be part of Smartlink, or it has to be part of Spanning Tree if you've enabled that. And UDLD is not going to make anything faster with Smartlink. You're still going to experience some sort of hit. Okay, so let's look at some of the configuration. Smartlink configuration. So in terms of the overall configuration for Smartlink, you have to define your VLANs, you have to define your trunks and the VLANs that you are going to be pushing across those uplinks. These have to be trunks. These have to be trunks. Just go to a laser pointer. These have to be trunks. Now, let's look at the Smartlink configuration effectively. So you define a group, a Smartlink group, that's mandatory. You then define a primary port. In this case, I've selected 1152. Then I select a secondary port, which is this other port 2152. I define my control VLAN. So this is what's going to used for flushing packets, flushing addresses, and you can see I've got that on the uplinks. Then I defined my two protected VLANs, but the control VLAN also has to be part of the protected VLAN as well. That's best practice. Then I've also defined a preemption, and I've also defined a preemption delay. And the reason for that delay is if I get a switchback from this to this when the primary is back up, I need to make sure I'm not black holing traffic, because we have to wait for the link to be up. Otherwise, you will black hole traffic. So typically, depending on what type of link it is, fiber will come up a bit quicker. You might have copper on those links. Maybe at some situation, you have to give a bit more delay. And also, we give up to a 5-minute delay, so 300 seconds, because you might want to let that dampen out a bit, that link. You might want to revert immediately, okay? Then you can see this load sharing. The main thing about the load sharing is very similar. I've got different protected VLANs, but you can see I've switched around the port. So my primary is now 2152, where it was 1152 before. So I'm now distributing the VLANs evenly, with this dotted line being my primary for my second group and secondary for my second group. Now, when you configure it, you'll get a couple of warnings on that interface. You'll get primary, secondary port should be tagged member of a control VLAN, which I've got here. And then it will say Smartlink will not participate in spanning tree. We know that already, but it gives you the warning. Now, the other important thing is we have to make sure the control VLAN is propagated across the whole of the layer 2 system. It's got to be layer 2 all across here. So all the switches that are upstream from your Smartlink must have this Smartlink receive control VLAN configured. So here I've got them configured on the west, this core switch, and on the east switch. So that's mandatory to have that. So there's 2 parts configuration down at the access layer, or the Smartlink switch. It doesn't necessarily have to be an access switch or access layer, and then upstream. So some other important things to say. We do support lags as part of a Smartlink group. There's no restriction of mixing lags and Smartlink. So you can see I've got a lag here and a regular port. So it makes no difference. And then finally, if you have a lag and a member of that lag fails, you will not switch across and revert. It will stay active. The whole lag has to fail for you to make a switch over. So you need to make that consideration in your designs, okay? So in terms of best practices, this is where we see typically Smartlink will be deployed. So this is the classic V shape. So that's layer 2 all up to the distribution aggregation, and layer 3 up to the core. Okay, so what happens if there's a failure? I've got VRRP as well deployed. So that's typically in this scenario, VRRP deployed. You could be doing that if you're not doing VSX, for instance, and you're going this route. I've got a primary gateway here, a backup gateway here. I fail this link here. This becomes my active link going towards the east. What will happen is that the traffic will still go an extra hop because my VRRP hasn't actually moved. So I'm going from 1, 2, 3 hops to 1, 2, 3, 4 hops. Still, you'll find, even though it's a suboptimal route, we're getting very fast failovers. And I'll show that in my demo. Again, you have to have this IP neighbor flood command, because when the MAC addresses change here and we flush the packets, we want the SVIs to be able to learn quickly. And here in this instance, we got this SVI on this one VLAN. So it's recommended to do that. That's really for very large scale deployments. You will find it noticeable. On smaller scale, you will not find that. Then the secondary primary version, the preemption I talked to you about, you need to make sure you have that timing set up correctly for whatever type of link you've got. So if this is fiber, yeah, 4 seconds will do for the preemption on the configuration here. If it's copper, you might need to extend that because typically it takes longer for a copper connection to establish. And then finally, if you want to dampen it, then you can extend that because you might possibly have a flapping link or a flaky link, okay? And then it's important to maintain this layer 2 ring. That's really important. I've just provided a bit of configuration here for you to see on the VRRP, the neighbor flood. That's sort of not very common that you may not use. Then we've got the Smartlink receive control VLAN, and then the preemption delay and the control VLAN. Okay, not a similar type of but a chain topology here. Not ideal, really, very suboptimal routing. Again, this can be used. Typically, that might be because there's no connectivity available between east and west. But typically, if you can, you would want to bring the layer 3 boundary down like the previous example and have a link in between here, maintaining layer 2. Same sort of best practices here. Okay, again, ERPS can coexist with Smartlink. Here we've got the ERPS node actually being the Smartlink and subtending the network off of here with the control VLANs. Here you have to be careful in terms of where do you place your layer 3 default gateway effectively, or your yet layer 3 node. It could be in different places for different VLANs. Again, something you need to be aware of if you're deploying something like this. But again, it's what the point of this is, it's feasible and possible. But and also if you're migrating for, say, Comware, it could be a good option for you to do something like this in terms of connectivity. Okay, so let's review some of the best practice takeaways. So you need to plan your layer 3 boundary in the topology, and it varies obviously. Here in that scenario, we have it here. In this scenario on the right, we've got it, the layer 3 boundaries here on this router, and here, well, it depends what you're doing, okay? Tune the preemption delay, very important. Wait for the link up as a minimum. Maintain the layer 2 ring for flushing. Just plan any layer 2. So if you do have spanning tree and you have Smartlink on the same switch or the same arena, then you need to be careful from the caveat I explained to you about earlier. It can cause loops if you don't have them assigned to either. You have a control VLAN and the protected VLANs. They need the control VLAN needs to be in the protected VLAN list. You see that in the configurations. Use multiple groups to load share the VLAN, but remember, this is not a hashing function, so it's not done on source destination or anything like that. It's just a simple, crude load share distribution, effectively. And please use neighbor flood on the SVIs for the north to south links coming downwards in this direction. Okay, some troubleshooting commands. So you got to show Smartlink flush statistics, so you can see the statistics on the upstream switches. Then you've got a show Smartlink group, where you can see a number of things, including the preemption delay, the control VLAN, the flush statistics. You can see I've got 5 and 6, which make 11. So I've received 11 flushes. I've produced 11. So you can sort of see from the sync that I should have the same everywhere. That would point to a problem if you didn't have that. Again, I've now failed this link. It's switched over and I've got 1 extra flush packet, and I've seen that the flush packet has incremented here upstream. You can use a clear Smartlink statistics if you want to as well. Okay, we've got some diagnostic dumps as well. So diag dump basic gives you very similar information as previously. The extra part that we can see is we can see who's the active link, who's the backup, and are they forwarding and blocking. And typically, if they're active, they're forwarding. If they're backup, they're going to be blocking. And you can see the associated VLANs. This is just shown for one group. There's also a daemon running, so you can do a show events on Smartlink. You can debug a whole plethora of Smartlink events, and then you can trace through. Okay, let's switch across to a demo. Let's find that demo. Okay, let's go across. Can you see that, Ruben?
Yes.
Perfect. Great. So let me explain what the demo looks like. So I've got a traffic generator here in the south. I've got 12 streams going from south to north. I've got this classic VRRP gateway. I've got I'm just looking at one protected VLAN. I got VLAN 1000 as a control VLAN. Primary VRRP gateway is going to be here. Backup, I'm going to fail it. We're going to see the suboptimal route and see the failover loss, and then I'm going to revert it back, and you'll see you see the reversion loss as well. So that's the overall. And if I've got time, I'll actually show you without the preemption delay. So this is a 6200 in VSF. So it also operates in the VSF stack. I haven't mentioned that before. So this is I'm on a 6200 here. So I can just do a show Smartlink group. I can see what's active is my primary, my backup. That's pretty much all I want to see right now. I'm going to go up to this core switch 1327, and I'm going to shut that shortly. But I just want to show you I'm not running any spanning tree on this access switch whatsoever. So these are the 12 streams I've got going on through this demo. Okay, this is more of a solution demo. Remember, this is not, I'm not here just to show you the loss. It's about to show you the solution. So this is not showing at scale. So if you want to scale it, then we've got figures that are coming out shortly. So I've got traffic being transmitted about 13 megs per stream and being received. I've got no packet loss here, and the figure we're interested in here is the packet loss duration when I make a failure. So let me go up to the this switch and make sure run current context. So I'm in the right. So these are you can see these are the VLANs, and this is my control VLAN. And from the diagram, we know that. So I'm going to shut that link. Let's go back across to the Ixia. We should see an outage very shortly. There you are. You can see I've got a 90 millisecond outage on that failover. That's about 20 times quicker than spanning tree. If I just go back across, we can see now that the primary is down and the secondary is now active. I could do a show. So this is on the upstream. You can see I can monitor the flush statistics. And okay, let's have and you can see the flush. You can see the flush count here. Sorry, so the flush count here is locally. So let me just go back and clear these statistics on the Ixia. So wait for the reversion. Just bear with me while they clear. Gives a few seconds. Okay, so that's cleared. So I'm going to go back up to the core and enable that port. Now we're going to wait a few seconds because I'm waiting for this preemption delay. I'm waiting for the link to come back up. Should take a few seconds. We should get a hit very shortly. Okay, you can see I've just had that hit. I just got a 7 millisecond hit. So that's like, oh, that's a very good. I mean, it's so much more faster than spanning tree. And then if I go back to my 6200, you can see that my primary link is back up, and the backup is in the secondary is in backup. So in summary, we've covered an overview of Smartlink, some use cases, some details and caveats, some configuration and best practices, as well as covered some troubleshooting commands. And in the demo, we saw the failure in one scenario going at 90 milliseconds and then the reversion just around 7 milliseconds. So I hope you now understand Smartlink and you find that useful and informative. Thank you for watching.